Hello, everyone, and welcome. Good morning, good afternoon, good evening, depending on where you're at in the world. Today, you're joining us being Solona and ID Wave, for CBRS networks for shipping yards, ports, and warehouses. Now, there are a lot of folks that have registered for this webinar, so we're just going to give them a minute or two to still filter in. However, just buckle your seatbelts and get ready, because it's going to be a wild ride through the worlds of warehousing and logistics. In that time, also, you'll be seeing our deck will be popping up here in a moment, and we'll get going. So just give me a moment and we'll get right back to you. All right, let's get underway. And also, thanks for folks who have already jumped into the chat function. This is going to be something I'm going to talk about in just a moment. We joined and let folks still filter in. So for those of you, James, Olivier, Amber, and James, we do have sound. So thank you for joining us. And today, as I mentioned, CBRS networks for shipping yards, ports, and warehouses will begin. Now, on this journey today, we have two folks that are leading us through. These are experts in the industry. Jamel Ramul, who you may have seen in a variety of events and also online for videos, webinars, that sort of thing, from IB Wave, is going to be one of our speakers. And the other is Ozer, Ozer Dondermasiolu, who is our VP of Marketing at Solona, also my boss, so treat him well. These guys are going to lead us into the content for today. Now, I would say, before we jump into that content, there are a few housekeeping things to talk about. Some of you have already found that chat function, which is great. Keep using it. You can ask questions of other attendees or of the presenters themselves or the organizations, because we have members of both organizations that are here to answer questions as well. Feel free to ask questions using the questions function. In addition to that, there will be some poll questions. We would love to see you participate with those poll questions. Answer multiple choice to give us a better idea whether we're on the mark or off the mark in our content, and where we may need to provide more detail or just assurance that we're hitting what you need to get out of this. The presentation slides will be available to you in PDF format after the presentation. And of course, because we're recording this, it will be available online on demand off the Solona site. In addition to that, if you have a thirst for more information, you can always visit us at solona.io/journey, or visit the IB Wave site, where both sites are packed with plenty of material to keep you entertained for hours and infotained for a lifetime. But enough from me. Let's get into the show. This is where Ozer will take over and jump into private LTE use cases for the supply chain. So Ozer, it is your time.
Awesome. Thanks, Greg, for the introduction. Hello, everyone. Great to see such a large crowd join us for this very, very hot topic. Honestly, star of the show is Jamel, because he has a live demo and I don't. We were thinking about doing a live demo for the Solona platform, but I think we're going to run out of time. So we kind of removed that from the agenda. Although you can watch a live demo of the Solona solution on a variety of different properties online, and join us for a live demo session, dedicated live demo session as well in one of our other webinar series. So let's get started. Many of you probably know what CBRS is, but just a refresher in case you don't spend your everyday thinking about CBRS like we do. So we believe that it's the most exciting news for enterprise wireless since Wi-Fi. I'm coming from a Wi-Fi background, spent 14 plus years at Aruba. When I started working on Wi-Fi solutions, it was just Intel Centrino chipsets running on a laptop, and then iPhone happened, iPad happened, and the rest is history. The device ecosystem for CBRS, as you can tell by the images on the right and that URL that I just gave, solona.io/devices, you already see, just 1 year into the ratification of this new spectrum by FCC, you already see 100+ devices, models supporting this new spectrum. When they connect when they run on the CBRS spectrum, when they operate on the CBRS spectrum, they're supposed to use LTE 5G cellular wireless. This spectrum is about 100 to 150 megahertz per AP, depending on where you are, depending on your neighbor networks and things like that. That's our estimate, that you're going to get that much spectrum per access point to choose from. Each access point utilizes somewhere between 10, 20, 40 megahertz channels, and these clients get somewhere between 50 to 150 to 200 megabits per second performance. Again, depends on the AP configuration, rate versus range, the network design, and device capacity, etc. So it's a pretty healthy bandwidth, healthy amount of bandwidth for LTE 5G devices connecting in a private enterprise setting, right? This is designed for interference-free operation of LTE 5G cellular wireless within an enterprise setting. It is not, you have to go and grab some expensive licenses from FCC or partner with service providers. This is you deploying an access point indoors and outdoors, getting access to LTE 5G wireless on the spectrum without having to worry about licensing fees. We take care of the complexity of which AP, which device is going to operate on which channels in that chunk of spectrum. I want to double click on the topic of interference free, because by design, no two CBRS access points that are neighbor to each other supposed to interfere with each other. That's how the whole standard and the CBRS operation has been designed, which is very, very attractive to all of us wireless professionals. So what do we do in that mix? We take the spectrum, we take the access points, and the LTE 5G cellular wireless. We provide a single package solution that enterprise usually like to see, right? I want to deploy indoor-outdoor access points, CBRS LTE access points, SIM cards that go into those cellular wireless capable devices that I just showed you, manage the entire network from a single dashboard, extend the platform software capabilities to on-premises in case we need to prioritize, secure, process traffic locally within an enterprise environment. So we call that specific component, that specific extension of our platform, to an on-premise or an edge cloud extension, Salona Edge. I'm going to show you how that looks like in a network diagram. We deploy that on an existing enterprise network. So just like you integrate an Ethernet switch, a router, a firewall, a Wi-Fi access point to your current network environment, you just do that here. Same idea. And our goal is not to take away from the sophistication of LTE 5G wireless, right? We know that cellular wireless is highly dependable, highly predictable, reliable technology. We don't want to remove any of that. We just want to make it easy to consume. So it's the same sophisticated cellular wireless technology that we have all been using for 20+ years, but translating to enterprise environments for the first time, because the spectrum is now widely available for us to just get going really quickly. Okay, so that after that quick intro, let's dive in a little bit deeper. How does this look? Let's say that we have the warehouse and logistics environment that Jamal is going to dive deeper into. How does the network actually come together? Let me start from the left. You would have devices in that environment, cameras, barcode scanners, laptops that may not be using cellular wireless modems inside. For that, you would have to translate Wi-Fi or Ethernet traffic to CBRS LTE wireless. So for that, you might use a Sierra Wireless or a Cradlepoint gateway. And we have some recommendations on this front, which devices do what. So I have some upcoming slides on that piece. Or you might have some devices, new generation of devices, ruggedized tablets, smartphones, laptops, two-way radios that might just take Salona SIM, operate directly within the CBRS LTE wireless spectrum. Those two sets of devices can run on the same network. CBRS access points are plug and play. You install them on your existing switching infrastructure, and you're off to the races. They check in with our cloud portal called Salona Orchestrator that is running in the public cloud. That's where the management of device groups, application types, SIM provisioning, variety of different network configuration lives, in addition to some smarts around artificial intelligence and machine learning. But in summary, access points receive who they are, what they're supposed to do from Salona Orchestrator. One of those instructions is for access points to figure out where Salona Edge is. Salona Edge lives right next to your critical applications. What we have seen become really important for private LTE today, as of today, is that it's a great match for critical applications that have to work, right? And for a variety of different use cases today, we utilize Wi-Fi. For a variety of different use cases today, we might utilize public LTE connectivity. But sometimes there's a intersection point where I have a critical application. I need it to operate in an interference-free spectrum. I need to assign highly predictable service levels to that application. And as a result, I'm using private LTE. So many of those apps rely on Salona Edge to be on premises, or at least very close to the on premises sites, also known as edge clouds. So Salona Edge is a software-led platform, cloud-native software platform. It can be installed just like an application on virtual machines, on premises, bare metal hardware, public cloud, private cloud, so very flexible. Wireless traffic from the devices through the access points, through your LAN infrastructure, travels through Salona Edge, and that's where it meets the rest of your network. That's where the wireless traffic gets encrypted, decrypted. One important point to highlight here is, since we're utilizing SIM cards for all traffic types, there's no concept of open SSIDs here. Everything is encrypted end-to-end at all times. The default mode of operation, and the only mode of operation, is device-level authorization and encryption, which is, again, another very attractive point for critical applications and device rollouts. So with that, let me give you some additional clarity, maybe peeling the onion a little bit more. Inside Salona Edge, the RAN combination, the access points, and the edge combination focuses on one thing very carefully. How are we going to slice and dice the network resources between different applications and device types, which is what we call microslicing. It's a patent-pending technology. It's a very unique technology, and it's, we believe, the only way that an existing enterprise network can be translated to cellular wireless. So in this configuration, Salona microslicing policy configuration, you essentially get to decide which devices belong to which IP subnets / VLANs in your core network, what type of network access policy they should adapt to given your corporate policies, and more importantly, what type of application service levels we should guarantee for these different flows. In LTE 5G wireless, there is the capability to say, I'm going to prioritize one application over the other, but I'm also going to assign a specific throughput, latency, jitter, and packet error rate metric to that application. So it's QoS++, as I like to call it, which is, again, very attractive to those critical applications and infrastructure that you want to make sure has great performance on wireless. Okay, so let's talk about use cases. That's the intro to the spectrum, to the technology, to different device types and our architecture and how we're tackling the problem here. Now, we have a private LTE network. We can deploy it in a logistics warehouse, but why? We have a lot of customers focus on ruggedized tablets for data entry, staff operated, heavily mobile. They have to be ruggedized for obvious reasons, and they're mainly used for barcode scanning, communication, and data entry. Push-to-talk voice communications is top of mind. Thankfully, Motorola actually has a great solution there, which I'm going to talk to you about. Many of these facilities have outdoor yards where vehicles moving around might be picking up products, delivering products to the warehouse, delivering products out of the warehouse. So that vehicle itself can be a small office, and that small office requires different needs. It might have a video camera on it. It might have a voice headset. It might have a laptop for the driver or a ruggedized tablet. And that small vehicle needs to be treated maybe with Sierra Wireless and Cradlepoint Gateway so that it stays connected with all the devices inside. And video surveillance is, of course, top of mind, whether it is just for the sake of public safety or we're counting the number of vehicles in the outdoor yard, number of people inside, and we're kind of optimize our process, business workflows as a result of the data we gather from that video capture, right? So which is also known as computer vision. All right, so this is what we're seeing actively in our pilots, in our POCs and production deployments. And of course, this extends to key special use cases in transportation yards. Similar set of environment, but somewhat different because these yards can be much larger and much tougher to provide wireless coverage for, given crane operations and tons of trailers stacked on top of each other, right? It's never a fun day for a wireless engineer trying to make wireless connectivity work here in these environments. In addition to the use case that I just mentioned, it's probably remote control comes into play quite a lot here. So many of these cranes might require remote operation, and that crane needs to move around the facility, perhaps sometimes in an autonomous way, but it needs to stay connected. And so you're sending instructions to the crane, receiving telemetry from the crane, but you're also seeing what that crane is doing with real-time video. So it's very challenging environment, but something that requires specific throughput and latency assignment, going back to my micro slicing comment. Again, you have vehicles that need to be connected here, staff operating tablets across the yard in an outdoor environment. You have video surveillance cameras, etc., that I just recently mentioned. So how our deployments have been looking so far? We have been lucky to support some interesting use cases. First one comes to mind is a deployment with automated mobile robots. Here, the environment is just really run by robots, people supporting, and these are racks and racks of products in a warehouse, and picking up and storage of those products are done using these robots that used to be Wi-Fi connected, but now it's transitioning over to CBRS LTE. Wi-Fi network stays, supports users, their devices, tablets, smartphones, everything else, but the robots get their own express lane of transportation on the wireless for wireless connectivity. We can guarantee lower latency when they're running on a CBRS LTE network. We can cover extra areas with a single CBRS access point up to 10x more coverage compared to the previously designed Wi-Fi network. But essentially, it's a way to extend the reach of wireless connectivity in this warehouse. Another use case that we run into quite often, and this is just one of those examples, large retail. On the front office, we're using Wi-Fi for guest access, for staff communications, everything else. But in the back office, where there are some challenging RF environments for coverage, capacity, and we need a clean spectrum to operate in because we don't want the back office applications to go down, then we rely on CBRS LTE. Again, here, the coverage patterns of the APs, CBRS LTE access points, have been proven to be 5x the amount of coverage from the Wi-Fi access points that were in place, that continue to stay in place. So adding a private LTE network on top of the Wi-Fi network here wasn't too big of a leap for the customer. And the next step is to see how we can create an environment where the indoor and outdoor CBRS LTE coverage is maintained. Not in liberty to share customer names here, but just wanted to share real world stories from our deployments. Okay, just gonna go through this really fast to make room for Jamel's presentation. We have some recommendations on devices. We've been testing these devices for over 12 months now. They have been great partners to work with. Certainly, given your specific use case, if these devices don't meet the need, we can certainly offer additional recommendations. But top of the list is Motorola Evolve. If you're looking at a high ruggedized device for push-to-talk two-way radio communication, retail price is not online, so I figured I'm not at the liberty to share the exact price, but you can imagine where it might land, looking at some of the other rugged smartphone options out there. It's an Android platform, dual SIM, and it has been great to work with, solid performance. Samsung Xcover Pro retails around $500. It's Microsoft Teams optimized. I'm going to dive into it in the next slide a little bit more. Android-based, dual SIM, replaceable battery, ruggedized, very, very attractive. If you have smartphone applications in these environments, that needs to be adapted. If you like Windows, Zebra L10 tablet comes to the rescue. A little bit pricier, but the ruggedized features and other capabilities really justify that price. 24-hour battery, docking container support for those vehicle installs that I mentioned, and solid performance again. On the Samsung Microsoft Teams integration, just wanted to create this additional note. We're seeing this convergence between applications that are mission critical, devices that are used in these mission critical environments, and Wi-Fi CBRS LTE converging. So for Xcover Pro, you can actually program a physical button on the device to interact directly with Microsoft Teams app and start a push-to-talk session. So just like you jump on a Microsoft Teams meeting, you can jump on a push-to-talk conversation in Microsoft Teams by just pushing a button on the Samsung Cover Pro. So it's a great integration of the critical application with the device hardware. In addition to that, you can assign which application uses which wireless communication channel. So some applications can use Wi-Fi, some applications can use CBRS LTE simultaneously, depending on how you configure the Android settings, which is again very attractive because we never seen this happen before, and I think we're gonna see a lot more examples of this going forward, where a single device can actually take advantage of multiple lanes of wireless connectivity. Okay, so gateway router recommendations. Apologies for the image mishap there. Must have got warped as I was converting to PDF. So Sierra Wireless RV55, our recommendation for a compact rugged router that can be installed to translate Ethernet or Wi-Fi, most actually Ethernet traffic to CBRS LTE, comes with a single SIM. Cradlepoint R500 adds Wi-Fi capability. So you have Wi-Fi devices, you have Ethernet devices, you can convert them over to CBRS LTE. Again, great for those in-vehicle installs. BEC MX240, very compact, small form factor. It can, in addition to Ethernet connectivity, it also supports USB connectivity. So if you have some specialized machinery, that could also be a great option to just use this very small form factor device to translate traditional Ethernet traffic, IP networking traffic to CBRS LTE cellular wireless. So I'm going to close it out with a quick recap on why Soluna. You're going to run into these projects. You're going to discuss many of these use cases with your customers if you're a channel partner, ecosystem partner. If you're worried about deploying CBRS LTE, but you want to make sure that you select the right architecture, this is the cheat sheet. We provide, as I mentioned, a one-kit solution to ease the consumption of this sophisticated cellular wireless technology. We are designing a system that speaks the language of enterprise networking, whether it's to protect the application quality, enable a device application level network access and policies, or if that means to seamlessly integrating with your existing infrastructure. We want to make this as enterprise friendly as possible. On the cost metric side, we can share a lot more details offline, but essentially we are designing our system to be in alignment with Wi-Fi investments that you might be doing for a given square footage. So we want to match or beat that pricing so that we don't cause sticker shock. We're not trying to necessarily replace any Wi-Fi networks, as mentioned before, but we also don't want to cause a sticker shock. So we kind of got Wi-Fi pricing as a guide for us to be friendly to your existing enterprise networking budgets and spending. And lastly, we do not charge per SIM card, which is generally has been the tradition in public or private LTE networks. It's a single package, comes in a software as a service subscription, instead of having to charge for data usage or having to charge for a SIM usage in the network, which essentially keeps the budget spending in line. So with that, I'm going to hand it back over to Greg and go to questions tab and see if you have any questions for me. Greg, back to you.
Thank you very much, Ozer. And we do have a poll question. So what are your favorite use cases for private LTE in the supply chain? So I think let's go ahead and pop that up so you can give me the answer. There you go. So you should see that the poll just popped up. Now, if you wouldn't mind doing us a favor of selecting one or more of these applicable selections here, from ruggedized tablet connectivity to robotics, wireless connectivity, in-vehicle routers, and remotely controlled machines with computer vision. Yeah, just pop that stuff in there and we can start getting a look at whether we are or are not on the right track with this content. I'll give you a moment. All right, so while you are submitting your votes, we can move to the next slide, which thankfully we can get to this content and you can not hear my voice anymore. So Jamel, let's look at designing this mobile network in the supply chain.
Thank you, Greg. Thank you also for your great presentation. Let me share my screen. Okay, should work now. Okay, hello everyone. Jamal Ramul. I'm sales engineer and also product owner at iWave. I've been there for like almost 4 years now, and in the wireless industry for more than 15 years. And contrary to Ozer, I've been in the cellular space mainly. So I've done a lot of LTE designs using the iWave software before. And today I'm going to talk a little bit about the different challenges we have when designing LTE network, and in this case, a CBRS private network or CBRS-based private network for a supply chain like shipping yards, ports, and warehouses. So let's get going. For those of you who don't know iWave, I have a quick slide. So quickly, iWave has been around for more than 17 years now. We have a variety of solutions for indoor, outdoor, wireless, and wireline connections. We have over 1,200 customers around the world, excellent customer support, a lot of network design worldwide. We're done using iWave software, so we're kind of the standard, especially for indoor or in-building. And we have a certification program where we have many people certified using our software. This is some of our customers, and this is basically the list of the tools we have. So we have different tools for different use cases, depending if you're doing cellular, outdoor, indoor, Wi-Fi only, public safety, fiber, or any wired network. And then we have like collaboration platform and cloud saving. The topic today is mainly how to plan, design, deploy, and validate a CBRS-based private mobile network, right, across. In this example, I'm going to focus more on the warehouse, but it could apply to different supply chain facilities. And what would be the different solution that iWave suggests to use is three main tools. We have the survey app running on Android that could be used to do like site documentation, like during the planning phase when you go on site. During survey, if there's any pre-existing network, which might not be the case for CBRS, but also to use it for validation. And you could also use it to do heat map interpolation based on that survey data. The design software is the one we're going to mainly talk about today, is the one used to do the predictive modeling and to do also survey analysis and use it to optimize the network. And we also have our site management central hub called Unity, where you could have a full visibility of the network. So how do we recommend basically using our tool to design, let's say, a CBRS network? The best would be to start with a template. And in this case, you might have like a default CBRS template or like a warehouse specific template where you have everything preloaded. Let's say project properties, component database, what is the technology you're using? Is it LTE, LTE-A, or 5G? Are you adding Wi-Fi to it or not? You define all the network parameters, the compliance, pass or fail for the predictive modeling and for the survey data, and then any customized reports. So once these define that the first time, then they are saved either in Unity or on the cloud or somewhere. And then each time you start a project, you don't have to do it again. So you start with your warehouse template, you create the project, you do your site visit. If there's anything existing, you do a survey maybe in the future. Then you do your 3D modeling, predictive design, you generate the bill of material, you send that to the deployment team, and then you get as-built documentation. Then you do your post-install validation survey, and you might need to do it once a year for your maintenance. Now, how do we create a template, right? What are the different requirements that need to be preloaded for a typical, let's say, warehouse project or any supply chain facilities? So we're gonna go by use case, and you saw that there are different use cases. You might need to use like ruggedized tablets, gateway, video camera, either connected to the gateway or like body cam that connect directly wireless. And you also have a voice application, right? And for each application, you have some minimum requirement, right? So for the signal, for example, we're talking RSRP. Let's say a tablet, you're looking for 900 dBm. A gateway may be looking for higher because you need higher SNR, higher throughput. And then video, voice, they have different requirement. And this is just examples, right? It could be different. And then why do we need different signal levels? Not just because of the sensitivity, because in LTE, usually the device, they have pretty much similar sensitivity. It's because the required throughput by application, right? If I'm using a tablet, maybe I need just data, and maybe 1 meg minimum is enough. But if I'm using a gateway, I might connect this gateway to different devices. So I might need, let's say, 4 cameras connected via Ethernet. So I might need 20 meg. And then the cameras or the video, depending on if I'm doing 4K or not, night vision or not, is it mobile cameras, let's say body cam, or fixed cameras connected to the gateway or not, we're talking maybe 5 meg. And we're talking mainly on the uplink and not on the downlink, right? And then you have voice. Usually voice, we're good with just 0.5 meg, right? So I'm looking at something, the maximum achievable data rate I'm looking at is 20 meg. And for that, I need 90 dBm RSRP because I need high SINR, right? And then for SINR, since there is like a relation between the throughput and SINR, you might want to get different SINR values. And then you might not need high SINR everywhere. So your minimum acceptable SINR would be 10. And then you define, okay, I need it 90% of the time, 95% of the time, 80% of the time, depending. And then we need to talk about the overlap and redundancy, right? So usually you need the handover, which is when something is moving, right? Let's say a gateway is mounted on like robots or whatever, autonomous vehicles, and they're roaming around the factory or indoor, outdoor. So they need to do handovers, switching from a cell to another cell. So you need at least 2 cells. But if we're talking geolocation, then you need 3 cells, right, for triangulation. And except maybe for voice, where you only need the handover and maybe a backup if any cell fails. So at least you have another cell for redundancy, right? So we're talking something like 3 service count 95% of the time, maybe just office area. They don't really need 3 cells, they need just 2. So that's basically the different requirement you would look like. It's going to depend, obviously. It's case by case. But if the devices are always the same and the facilities are similar, then it's it's good to have a template that everything is preloaded and predefined, right? Now, you do the 3D modeling, you do predictive design. This is just a screenshot of a warehouse I'm going to show you. You have the different racks, and you have the goods in the racks, and then you have your heat map. As-built documentation during deployment, it's good to use our mobile to kind of put push pins and document where the small cells were installed, where everything is there. And then use also the mobile app to do the survey, right? Post-validation, post-install validation. You could use the Android capabilities to gather the cellular data, or you could connect to any third-party tool like a scanner or anything. With that, I'm going to jump to the iBwave design and show you a warehouse project. First of all, talking about the templates, when you create a template, you could define, let's say, the units, the part ID, how you want to generate it. You could define the wireless service here. I have the 3.5, the CBRS, and you could define the output map, right? So each output map, I could define it here, the RSRP. What is the compliance I'm looking for? Neg 90, 95%, right? What is my downlink throughput I'm looking for? Like 20 meg. What is the uplink I'm looking for? 5 meg, right? What is the signer I'm looking at? What's the service count? Everything is defined and saved. So once you start a project, you start with this template where everything is preloaded, so you don't have to do it each time. And you define your network optimization, all the parameters, then you start your project. And so this is an example of a warehouse. And you see you have the different racks here and shelves with the goods. And then what I did is I used the Celona indoor small cells. And you see here they are wall mounted. So you see an arrow indicating where they are pointing. And I've used 4 channels, 420 meg channels. And you see we have they are color coded, so it's to avoid confusion, because it's the channel number in LTE are not as easy to see as in Wi-Fi. So they have a huge number. So we have 4, let's say, best use case, well, average use case, you will get 8 10 megahertz channel, which is the general license that you should get access to easily. So if you convert that to 20 meg channel, you have 4 20 meg channel. So with 4 channel we use, I color code them, and then I try to separate them so they do not overlap to minimize interference. And then you have the regular Omni. They don't have any arrow. They just Omni ceiling mounted for the office space. And then you have the outdoor small cells mounted on the roof with an outdoor panel or directional antenna pointing toward the different area. Let's say the where the trucks will go, where the entrance, the parking lot, and stuff like that. And then you could model the trucks or model the shipping containers or whatever you need to model. So if I go to the prediction, and if I run my RSRP, it will look like this. So the indoor coverage and then the outdoor coverage. And then you see that I'm meeting my minimum neg 90, almost 99% of the time. The downlink data rate, I'm having the minimum 20 meg 96% of the time. And then the uplink, I have my minimum 5, 100% of the time. So I have more than 5. So, and then you have the signer, which is, we wanted minimum 10, and it's 94% of the time. Then the service count, and this is where you would need the overlap between the cells. And you see inside the warehouse, when there is open space, it's high overlap, so you see multiple cells. But as soon as you get outdoor, you may get 2, 3, well, at least we're getting this minimum 3. And then maybe in the office space, you don't get high count, but it's not really required, right? And what does this look like in a 3D view? And that's the nice thing with iBwave, is that you could actually have a view of your warehouse. And let me just remove the prediction so you see the 3D model. So that's the warehouse with the outdoor, the parking, and then the road. And we could add like trucks and containers and stuff like that. And then I could go inside. Just do this. So I could go inside and see the different racks and shelves and the goods inside. And then if I want to see the prediction, I add the prediction and I could see what's the coverage, and I can actually go inside and see where do I have good or bad coverage. And you see sometimes between the racks it's a little bit weaker, but it's still good. It's still in the 90s. It's orange, right? And then I have the outdoor, and that's what basically I have with the 3D view. Now, once I completed this project, I might want to go on site and do a survey, right? And for that, we're going to use our mobile app. And this is our iWave mobile survey. And you have the plus sign here. So when you open the app, you have the list of projects, but you have the plus sign to download project from the server or create a new one. Here I already downloaded it. Here's the warehouse, and here's my my design. And then I could start documenting, adding pushpin, adding pictures, or I could do a survey using just the internal Android capabilities. So I could start a new survey, and I could do either Wi-Fi, cellular, or both. In this case, we're just introduced by cellular. I could do stop and go or continuous, and I create my survey, and then I could start walking somewhere here. Let's say I'm inside the warehouse here. I'm walking, and then maybe I'm gonna turn somewhere here. So I'm gonna start walking inside the shelves, maybe here, and go all the way down between the shelves. Right, and it's recording the points while I walk in. So once I've done all the walk, I could hit done, and then it will show me the coverage, and then which channel it was recorded, the PCI, and then I have the RSSI, RSRP, RSRQ, and the signer map. And at each point I could click and see actually what was the coverage here, which carrier, the different KPIs for each data point. And if I show you, let's say, a complete project where we did our office here, you see the coverage all around. And then if I do interpolation, I see my heat map, and I could see the different channels, the different PCIs, and then the different map I want to see. So with that, I think I went a little bit over the time, so I think we need to leave some questions. So thank you all for attending this webinar, and let's go back to Salona.
Thank you very much, Jamal. I really appreciate that. Now, we did have another poll for you around key capabilities. So if you were to look at these key capabilities that you have top of mind for your wireless projects, what would those be? Capacity planning? Is it around RF coverage? You know, what is the real concerns you have? Thank you very much for going to that slide, Ozer. So, you know, pop your answers in there. We'll just give you a moment to take a look and let us know. I'll tell you, indoor and outdoor coverage and capacity planning is taken off. That's good. Okay.
Well, a lot of tough questions for you ready.
Yeah, I think, you know, while we're getting that, let's get in these questions. So I see Ozer was pretty active; his fingers were flying, but did get to them all. So Ozer, any particular question you want to take off the bat, or to throw over to Jamel?
Yeah, absolutely, Jamal. I'm just going to start in the questions tab, sir. Thanks again for that demo. Phil is, I guess, making a statement. SINR output map will display if your APs are placed correctly without too much interference. I guess you would agree. Paul is asking, how are you getting 4 channels assigned from the SAS and the reuse?
I'm assuming I'm not getting any.
Got it. Yeah, so that task is actually up to us, Paul. We're just, as the infrastructure component, we interact with SAS certified SAS services. And after the customers give us their certified professional installer credentials, also known as CPI credentials, for spec CBRS installs, we kind of handle that complexity of interacting with SAS, so the customer doesn't really have to worry about what's happening behind the scenes. So let's close that. Olivier is asking, perhaps this is for me, a major use case for a warehouse network is product scanners, most of which connect with Wi-Fi. Are there any product scanners available for CBRS? There's going to be very soon one or two of them, not at the liberty to share, but they're coming. That said, an iPhone that supports CBRS, Samsung Xcover Pro that I just mentioned, Motorola Evolve, they do have Android and iOS apps that can serve the purposes of barcode scanning using their cameras on the device. But there are dedicated barcode scanner devices with CBRS support coming. All right. John is asking, any word on CBRS in Canada? One of the popular questions that we get in these webinar series. Not yet, John, but we're actively waiting. Jamal, do you know anything since you're...
No, it's really slow here.
Okay. Amir is asking, is our planning for private networks similar to public LTE 5G planning? It would be helpful if you specify the differences in our planning. I think that's for you, Jamal.
I think that the main difference is that you have more channel to use for the same band compared to the public regular cellular design, where you have different bands, maybe one maximum 2 channel per band. Here you have 15 channels to use in 10 megahertz, and you could have 7 in 20 megahertz, which is completely different, and you could have higher density because you have channel reuse. But it's only one band. That's the main difference.
Great, thanks for that. Paul is asking, okay, we answered that actually. Let me skip that over quick. Moving.
Oh, so did you speak about eSIMs?
I did. I answered it live, but happy to kind of touch up on it. So devices that we just looked at on slides and a variety of others do support physical SIM connectivity today. I would say many, if not all. Some are starting to support eSIM capability on the private LTE, on the private spectrum, on the CBRS spectrum, but very early stages. So regardless, we will support both methods. And right now we use programmable physical SIM cards. What that means is there could be a SIM card with multiple profiles on it, and those profiles can be changed over time. And if one of those profiles happens to be a private spectrum / Solana profile, we'll be able to onboard that device too. Now, to make things easy for our customers, of course, we provide a physical SIM card, actually 20 physical SIM cards with every indoor AP we ship, and 40 physical SIM cards with every outdoor AP we ship, and then we can ship even extra if we need to. So to make things deployments much faster, right? So, but eSIM cannot come soon enough. We're looking forward to it. It's going to simplify a lot of our lives because you do it in software rather than physical SIM cards. So that's going to make it easy for everyone. All right. John is asking, how is power delivered to the outdoor ruggedized AP? Can I upgrade to 5G without upgrading the radio? I can take this one. So John, outdoor APs that we provide run on AC/DC power. If you have AC source, there's a AC to DC adapter, but essentially that runs on a dedicated power line. And you can maintain your Solana software stack, configuration, operational model, network core, all the software components as you add 5G radios when they become available in our portfolio. But in order to get access to 5G wireless, you're going to need 5G radios. So today we ship CBRS-based LTE radios. Mohan is asking, is roaming between private LTE and public LTE in place? Yes, it's doable today. You can use an iPhone, dual SIM, one SIM for private, one SIM for public. Again, if you have a scenario where there's a single SIM card with 2 or more profiles on it, one of them being private LTE, again, you can enable the same. So it's technically doable today with dual SIM, but if there's a single SIM with multiple profiles, that's also doable. Olivier is asking, if you have multiple locations spread across a geographical area, can you push to talk.
I think it's point to point.
Point to point between locations. Today our radios do not support point to point or mesh configuration. So on the other end of the link, there has to be some sort of an outdoor CPE or a gateway router type device like Sierra or Cradlepoint to kind of maintain that link between the two sites. All right, Paulo is asking, do you have a list of acceptance KPI SLA for different private network scenarios? I think Jamal's list provides a good summary between video and voice and data, but not today, but it's probably a good suggestion that we should probably create one and share it with the community here. Rob is asking, a value proposition for private cellular is the customer owns the data as opposed to getting service from a licensed MNO. But what is the data? Has that been a topic of discussion with current customers during trials? Absolutely. So Rob, the data that runs on those smartphones, tablets, gateways, whether it's video, voice, traffic, it is local to that network, generally speaking. People want to keep it local, store it in your on-prem servers, process them within their own infrastructure. Some of our deployments don't even have connections. They don't even share a single bit of that data with external cloud environments. So that's doable. It's possible to run your application stack, of course, in the cloud, private cloud, and you can do that. But with a private cellular infrastructure like Solona's, you can just go fully private. But it is a very, very top of mind question that comes up from our customers. Okay, William is asking, when will CBRS standards be approved to support 5G? I think it's in the final stages of its ratification. I think the specification is pretty much done. The certification of devices haven't started yet, but they're imminent. So we're expecting that there's going to be a good chunk of the ecosystem also supporting CBRS devices, CBRS radios over the next 18 months. All right, questions keep coming in. I'm going to go down to see if we missed any. What will be the impact on latency, Laurent is asking, of using a gateway router for Wi-Fi devices? The latency over CBRS LTE can be brought down to 50 milliseconds round trip minimum. So I usually say 50 to 100 milliseconds additional, but then of course, you kind of look at the benefit of replacing wires, expensive fiber connections, expensive cabling with CBRS LTE backhaul for that gateway. And, the benefit might actually trump, the reduction in cost might be actually a good match for that additional latency, but it's not significant. Okay, moving on. Let's see if we can cover everyone. I kind of feel like this is a video game with more questions coming the more I try to answer. All right, I'm going to try to find one for you, Jamal. How to properly design for spectrum moves within GAA ban in CBRS when incumbents come online to ensure SLAs. You want to take a crack at that? William is asking.
So usually we know the incumbent which channel they are using, right? And I think the Celona free planner can show you that, which channel are available GAA for a license, which one are not. So before you start planning, you know in advance how many channels are available. Usually, I believe there will always be 8 GAA channel available regardless if they are used, because the PAL license is only 7 out of the 15. So you will always have 8 available. Now, if you're doing indoor, the 8 might be safe from any interference, especially if you're doing warehouse or any building that has windows that with high isolation or concrete. the 3.5 is high frequency, so it will not penetrate indoor much. So you will keep a good signer, you will keep your SLA. Now, outdoor is a different story. You may go with worst case scenario, use 1 or 2 channels, assuming that the others are used. That it's a case by case, it's location by location. But I would say you should probably be able to have 8 channels available most of the time. Are they clean? Indoor, pretty much. Outdoor, it's another story.
Great. Thanks for that, sir. Go through these really quickly. Carlos is asking for data coming from the CBRS LT and devices. Local traffic, does it require local P gateway? That P gateway functionality is one of the services, one of the microservices that runs in Solana Edge component that I showed in the architecture slide, Carlos, that essentially allows you to translate cellular wireless traffic to an existing VLAN IP subnet in your local network so that you can actually support this local breakout. But it's a very standard deployment for us at this point. Andre is asking, could you elaborate on interference avoidance between small cells on the same channel inside the warehouse? Perhaps you can take this one, Jamal.
Yeah. So if you saw what I was presenting, if you have a good channel reuse, like I was using for, it's a good to separate, to create a good distance between the same channel, so that the attenuation will do the job. Just the free space path loss will do the job. If you have 20 dB difference between the first cell and the second cell, you end up with 20 dB signar, which is good. Now, if you have one channel reuse, that's complicated. Then the best is to use highly directional antenna, and then you orient the signal toward one direction, and you rely on the antenna having a lower side lobe or minimum side lobe to not interfere with the other. So you would end up with some areas with bad signar, but overall your signar should be good. So distance between channel, if you can't, directional antenna.
Great, fantastic.
Hey, Jamal, there's one question that's specific to you that from Adam around IBWave adding automatic channel assignment for CBRS in the design automation tool.
Yeah. So we are planning to add a CBRS module to the Wi-Fi product. That's like exclusive news, maybe. So it will come probably in June, and we will, starting from that, so we will bring all the existing functionalities, and then we will start improving and adding stuff like auto channel assignment. We will filter all the channels and only show you the channels that are defined by this CBRS for the CBRS band, instead of being defined by 3GPP, where you have, I think, 1,500 or 15,000 channels, whatever. So since it's 10 meg or 20 meg, then the channels are known, right? Compared to when you use 3GPP spec, you have different channels. And once we do that, we have like the list of 15 channels, then we could do the same as we do for Wi-Fi, automatic channel assignment using those 15 channels. So that's on the plan. We should have that by the end of the year or before that.
Fantastic. Well, I think we have some more questions in there. We have some chat stuff as well, but we also have hit the top of the hour, and I know we're going to see a dramatic drop-off in attendees having to get on with their day. So for those who still have questions, please do reach out to us. We are always willing to stay in touch. There's a trial that you can take at IBWave. So start with the trial of the mobile survey product. Jamal and team can help you out in any way, shape, or form if you have questions about it. Their website is a great place to start, and mobile survey right there is the way to get involved in that. And of course, Solana. We would love to speak to you more, show you a little bit more about our product, our experience in these various verticals, and in particular to shipping yards, ports, and warehouses. We have a bigger story to tell and would love to tell it to you. So until then, we do thank you for your time. We thank you for your attention, and we thank you in advance for sharing this with your friends, your peers, and your organizations, so we can work together in the near future. Until then, have a fantastic day. Stay safe, stay healthy, and we look forward to seeing you on the next webinar.
Thanks, everyone.
Thank you. Enjoy the rest of your day.
By the way, I'm going to keep answering on the chat window and the question window if you guys want to still hang around.
Yeah, me too. I'm going to hang around a little bit so we can continue to answer the questions and chat. Thank you, everyone.